Morning, guys. Mrs. G is not going to actually be voicing over here because the microphone is having difficulty again, so you're not going to hear her today. What we're going to talk about today is balancing equations. Yesterday we talked about writing formula equations. In order to talk about balancing equations, you need to know how to count elements. So we're going to take a moment here. We're going to see if you can count how many atoms of each element are in these three compounds. So why don't you take a moment right now and pause and see if you can count how many sodium, how many hydrogen, and how many oxygen in sodium hydroxide. Do the same thing for lithium sulfate and okay, so now that you've done that, we're going to check this. The first one's not too difficult. There's a 1 understood to be in the position of each of these sodium, oxygen, and hydrogen atoms. Since there's no other subscripts, we just go for 1, 1, and 1 hydrogen. Okay. The subscript 2 on lithium here suggests that there's 2 atoms of lithium. The lack of subscript on sulfur is implied to be 1 atom of sulfur. And then the 4 on oxygen implies that there's 4 oxygens. When we take a look at calcium phosphate, I see 3 calciums. And then this 2 subscript has to actually get distributed into everything for phosphate. Since there's understood to be a 1 on phosphorus, it's P1 times 2 tells you that there's 2 phosphoruses. For oxygen, it's O4 times 2 is equal to 8 oxygens. All right. So the law of conservation of matter does have to apply to chemical reactions, so we can't create or destroy atoms, just like Dalton had said. No new atoms are created, no new atoms are destroyed. The only thing that really is going on here is that chemical bonds, which are actually measured in energy, are created, destroyed, or rearranged. So can we really conserve matter here? Let's consider the chemical equation for the formation of water. How do we do this? Okay, the mechanics of how we do it. The mechanics of how we do this. Usually the way I like to suggest that you balance chemical equations, you list out all your elements down the center underneath the arrow. Okay, so hydrogen is one of my elements, so I write H. And I also write oxygen. Notice there's no need for subscripts here because what I'm going to be doing is I'm going to be counting how many things are on my reactant side and writing it on the reactant side. And I'm going to be counting how many things are on the product side, how many atoms are on the product side, and put that on the product side. Okay, so for instance, I originally start out with 2 hydrogens on the reactant side, and I start out with 2 oxygens on the reactant side. All right, I see 2 hydrogens and 1 oxygen. So the way to do this is I'm going to write down what's called a coefficient. Coefficients are numbers that you can write in front of chemical formulas, and they mean that you're going to have more of that particular chemical formula. So if I wrote a 2 in front of one of these things, I'd have 2 molecules of it. Or if I had a 3 in front of it, it would mean that I'd have 3 molecules. Some people like to read it as molecules. Other people like to read it as moles. Okay. So in order to fix this, I need more oxygens. I'm going to write a 2 coefficient in front of H2O. That way I have more oxygens. As a matter of fact, I'll have 2 of them. Now, in doing this, I do mess up my hydrogens, and I changed how many hydrogens I've got. So now I have 4. This often happens in trying to balance a chemical formula, and once you write one coefficient, most of the time you have to write another, and then another. You have to undo what you have done. I now have to fix my hydrogens, and that's pretty simple. Hydrogen over here is elemental, so by putting a coefficient on it, I'm going to be able to change it to be 4 atoms of hydrogen, and this is going to be balanced. Alright, so in summary, these 2's that I've placed are called coefficients, and I'm placing them because I want to balance out how many atoms are on the left and how many atoms are on the right. Alright, so the purpose of balancing equations is to show how much of each reactant is needed to make a certain quantity of product. You can kind of think about this as being analogous to making cookies, having a recipe for cookies. A recipe for cookies would tell you how much flour, how many eggs, how much sugar, how many chocolate chips you need, and it would also tell you how many cookies it yields when it's done. Chemical reaction is very similar. What can we do to make sure that this is balanced out? Well, we can add coefficients like I've just talked about in the previous slide, and these coefficients wind up acting as a multiplier. So if I was trying to look at this and figure out how many carbons I've got, it looks like I've got 1 carbon here and 2 oxygens here. Here I've got 2 carbons and 4 oxygens. And if I'm going to look at barium hydroxide, you could probably press pause and see if you can do this. This is the toughest part. How many bariums, how many oxygens, and how many hydrogens? Okay, there are 2 bariums. This 2 is distributed into the hydroxide, so there are actually 2 oxygens times the 2 on the coefficient, so it's 4. And there are 2 hydrogens times the 2 on the coefficient, so there are 4 hydrogens. Some general rules for balancing. The first rule for balancing is make sure you've identified your products and your reactants. Make sure those equations are written properly and the formulas are correct. The second is to make sure that you count the atoms. Look for polyatomic ions on both sides. If I have nitrate as a reactant and nitrate as a product, I don't need to count nitrogen and oxygen separately. I can count nitrate as a whole unit. However, if I see nitrate on a reactant side and I don't see nitrate on the reactant side, it's separated into nitrogen and oxygen, then I'll need to count nitrogen and oxygen separately. Make sure to insert coefficients as needed. Remember, you're not allowed to change the formula, so you cannot change the subscripts. And you're going to balance 1 atom or 1 polyatomic ion at a time. Delay balancing elements. This is a hint here. Delay balancing your single elements until last. So if you see something that's elemental, like oxygen, or like oxygen gas, or like iron, all by itself, then you want to do that one last because that's going to help you out. Okay. Finally, verify your results. Double check your work and make sure that the numbers that you think you added up actually are correct. All right. So let's try one out here. Again, the way that I like to work these out as I start out is to write out the elements, a list of the elements vertically that appear on the reactant side. Sodium appears, hydrogen appears, and oxygen appears, so that's why I wrote it in that order. There's 1 sodium, there's 2 hydrogen, and 1 oxygen. Now on the right-hand side, I'm seeing 1 sodium. My number of hydrogens, now this is not in the same order, so I've got to be careful. I don't want to count my oxygen, I want to count my hydrogen. 1, 2, 3. I've seen 3 hydrogens, and oxygens I'm seeing 1. It appears that hydrogen's my problem. I've got 2 on the left and 3 on the right. One of the reasons why I've got 3 on the right is because of this single hydrogen here. Now notice my hydrogens over here come in pairs, so it's going to be impossible to ever have an odd number. So what I'm going to do is I'm going to put a 2 out here in front of sodium hydroxide. That way it's going to make the number of hydrogens even. All right, there's going to be 4 hydrogens here. That changed my sodiums and it changed my oxygens. There's 2 of each. So now I have to fix all of my elements still. When I come back over here to the reactant side, I'm not going to change my sodium because sodium is elemental. I'm going to go for the water first and try and fix things with the water. So I'm going to put a coefficient in front of water of 2. That way I'm still trying to fix my hydrogens. 4 hydrogens and 2 oxygens are what I get by doing that. Now this is good because that actually fixed my hydrogens and oxygens, and the only thing left is sodium. And I have elemental sodium, so my one change on elemental sodium is going to change only sodium. And now I have a balanced chemical reaction. I want to double check my work. I see 2 sodiums as reactants and 2 as products. I see 4 hydrogens as reactants, and I do see 4 as products. I see 2 oxygens as reactants, and I see 2 as products. I'm right. Okay. All right. So calcium and silicon and chlorine are the elements that I'm seeing in this reaction. It looks like 2 calciums on the left, 1 silicon, and 2 chlorines. A calcium, 6 chlorines, and a silicon. All right. Now I can fix whatever I want first. I could try fixing chlorine first, but chlorine's an element here, so I'm not going to bother with it. I think I'm going to do that one last. I can fix calcium instead, though, because if I fix calcium, check this out. I put a 2 here, and that changes my number of chlorines. So had I actually changed chlorine in the first place, I would be wrong right now. And I'd need to change it again. So calcium's done. The other thing to check on here, calcium's done, silicon's done. I guess chlorine's the last one, so I'm going to put a 4 in front of the chlorine here. And that's going to make the number of chlorines 8. Now I think I'm done, so I should double check. At the top, I see 2 calciums on the reactants and 2 on the products. I see 1 silicon on the reactants and 1 on the products. I see 8 chlorines on the reactants, and I see 8 chlorines on the products. We're going to try this one out. This is the methane combustion reaction, just like when we did the methane mamba. So I'm going to do carbon, hydrogen, and oxygen. It looks like there's 3 carbons, 8 hydrogens, and 2 oxygens. There's a carbon, there's 2 hydrogens, and there are 3 oxygens. Again, I'm thinking that I'll do oxygen last because oxygen appears as an elemental gas in my formula. So perhaps I'll work on carbons first. Carbon looks like it's going to be easy. I want 3 carbons on the right side. So 3 carbons will change my number of oxygens also to 6. Changing my hydrogens, let's see, I'm going to want 4 hydrogens, I'm going to want 4 waters. That way I get a total of 8 hydrogens. 4 times 1 is 4, plus the 6 that I've got there, that's 10 oxygens in total. So carbons and hydrogens look like they're balanced. I can now tackle the oxygens. To get 10 oxygens on the left side, all I need to do is put a 5 here, and now I have 10 oxygens. Let's double check up at the top here. There are 3 carbons on the reactant side and 3 on the product side. There are 8 hydrogens on the reactant side and 8 on the product side. There are 10 oxygen atoms on the product side, and I see 6 plus 4, that's 10 oxygens on the reactants. 10 oxygens on the product side. Okay. So, chemical reaction, homework number 2, clean sheet of paper, titled with your name. It helps if your period's written down on it. Go ahead and write these balanced equations. Press pause now,